finding distance using the Pythagorean theorem in 5 minutes. In order to find the distance between 2 points on the coordinate plane, you cannot measure it diagonally. Instead, you have to use the Pythagorean theorem by creating a right triangle. Let's get started. So the Pythagorean theorem can be used to find this diagonal distance between points A and B, if we make it a hypotenuse. So the first thing you need to do is to create a right triangle by drawing your own horizontal or vertical lines along these grid marks, like this one here. This line is creating the bottom of the right triangle, and this line is creating the right side of the triangle. These are called the legs. Now that you've traced along the grid lines, you can measure their horizontal or vertical length. So here we have a triangle with a leg of 6 and another leg of 4, and we can find the hypotenuse by using the Pythagorean theorem. Since we know the legs, that means we can erase and replace the letters A and B in the Pythagorean theorem equation. So A will be 4 and B will be 6. And C is the hypotenuse that we're trying to find. All we need to do now is take out our calculator and compute 4 squared plus 6 squared all at the same time. We can put it all in the calculator at once. That gives us the number 52. Once we know that the left side is 52 and the right side is c squared, we can use an inverse operation to clear that power of 2. The opposite of a square is a square root. We can use this square root feature on our calculator by pressing the second x squared button. Once you have your square root symbol, you can type 52 underneath. If you get a long decimal answer like this, you'll probably be asked to round it. Read carefully at what place you should round to. We're going to round to the 10th place. So that means the answer is approximately 7.2. Let's try a few examples. The directions state to find the distance from points A to B, rounding to the nearest 10th if necessary. So I'm going to draw a right triangle here on question number 1 by drawing a vertical line with a distance of 1 and a horizontal line that goes from -4 to +4, so that has a distance of 8. So my legs are 1 and 8. So that's 1 squared plus 8 squared equals c squared. 1 squared is 1, 8 squared is 64, and when I add these together, I get 65. Now I need to write that I'm going to square root both sides, and I can type that in my calculator. Square root of 65, and now I can round my decimal answer. 8.06. Now careful when rounding. 8.06, when rounded to the 10th place, means that I have to look next door at the 6, which is big enough to round me up. So the answer here would be 8.1. Let's do this again with question number 2. Create a right triangle. You can either create the right triangle like this, or you can create a right triangle like this. Doesn't matter which way it's facing, as long as you have that 90-degree angle. So it looks like my horizontal distance is going to be 5, and my vertical distance is going to be 3. So that means I have 3 squared plus 5 squared equals c squared, or 9 plus 25 equals c squared. This gives me a 34 on the left, and now when I square root both sides, I'm ready to use my calculator. The square root of 34 is 5.83. 5.83 would not round up because the next number is not 5 or higher. So the distance of this one will be 5.8. Let's try 2 more. Draw a 90-degree right triangle. Determine your horizontal and vertical lengths and put them in the Pythagorean theorem. 4 squared plus 9 squared equals c squared. I'm going to type it all at once this time. 4 squared plus 9 squared is 97. And when I square root both sides, my c will no longer have an exponent. So I'm going to take the square root of 97 and round to the nearest tenth, which is approximately 9.8. Last one. Create your 90-degree triangle. Take your vertical and horizontal measurements. 4 plus 4 is 8. Square root both sides. And now I'll find the square root of 8, and I'll round to the nearest tenth, 2.8. And that's how you use the Pythagorean theorem to find distance.